Yeah, నేను అట్లా సర్లే ఎడిట్ చేస్తాను. స్క్రీన్ పెట్టినప్పుడు ఇది నువ్వు వాట్సాప్ది అయింది
ఏది బా
టెస్ట్
అన్ని పోయినాయి
లేదు ఇప్పుడు ఇది అది అది వాట్సాప్ అన్నీ మేనేజ్ కింది
శశి ఏది నెట్ ప్రాబ్లం అయిపోయింది అయిపోయింది
ఇప్పుడు పాస్వర్డ్ ఎడిట్ చేయాలి. ఇప్పుడు లింక్ కాపీ లింక్ ఎడిట్ ఎడిట్ రావట్లేదు కదా ఎప్పుడే పెట్టింది
అప్పుడు మీకు పెట్టాను వేరే వచ్చింది డిలీట్ పెట్టేసాను
సర్లే ఇప్పుడు షేర్ చేసినా ఇది లింక్ ఇంకా సో ఇక్కడ మీరు కూడా మీట్ డిలీట్ కదా గ్రూప్లో కాల్ చేయాలి. ఇంకోటి అది లింక్ కూడా షేర్ చేస్తారు. గోటు మీటింగ్ లింక్ ఈ ఏరియాలో
నదీం సైడ్ కదా నదీం కదా నేను చేయను కదా నదీం నన్ను చేయొచ్చు వీళ్ళకి పార్టిసిపెంట్ రైట్స్ ఇవ్వాలి సడన్ స్కీమ్ ఎవరు లాగిందండి నది ఈ గోటు మీటింగ్ లో ఎవరు జాయిన్ కాదు మన వాళ్ళు మాత్రమే కిరణ్ మేడం లింక్ పెట్టినా సార్ చేసిన జాయిన్ అయింది సార్ ఒకసారి చూడండి జాయిన్ కాలేదు గోటు మీటింగ్ లో ఉంది మన వరకే అంట పార్టిసిపెంట్స్ అయితే యూట్యూబ్ లో ఉంది పెట్టేసిన జాయిన్ సార్ అంటుంది ఎక్కడ జాయిన్ అయింది మేడం జాయిన్ కాలేదే మీరు జాయిన్ అయినారు సార్ నాకు జాయిన్ అయింది సార్ గో టు మీటింగ్ జాయిన్ కాండి సార్ ఒకసారి.
Waiting to join the session.
ఎగ్జిట్ చేసి అందులో చూద్దాం.
కావాలి కదా లాగిన్ అడగాలి కదా, పర్మిషన్ అడగాలి కదా, జాయిన్ చేయమని అడగాలి కదా. అది రిఫ్రెష్ ఏం లేదు కదా. సార్ లాగప్ చేసి లాగిన్ చేద్దామా సార్? క్లోజ్ చేసిన క్లోజ్ చేద్దాం. ఆప్షన్ కూడా రావట్లేదు సార్. యాక్సెప్ట్ చేయాలి యాక్చువల్గా, వెయిటింగ్ టు జాయిన్ వస్తుంది. క్లోజ్ చేసుకుంటున్నాను. ఆల్రెడీ ఉన్నాను సార్. ఇప్పుడు నేను జాయిన్ అయితే కూడా వెయిటింగ్ టు జాయిన్ చేస్తాను సార్. బట్ ఇక్కడేం ప్రాపర్ రావట్లేదు. కన్ఫ్యూజన్ సార్. ఐ విల్ ఎండ్ సెషన్ ప్రిఫర్ కావాలి. టీటీ కదా ఇది. స్టార్ట్ నెక్స్ట్ గో కాపీ. నెక్స్ట్
సేమ్ లింక్ వెళ్ళండి సార్.
సేమ్ లింక్ అయినా షూరా?
మనమే ఫర్ ఎవర్ పెట్టింది
చూడండి.
ఇప్పుడు ఇచ్చినారండి. ఇప్పుడు ఇచ్చినారు. ఇప్పుడు జాయిన్ అయినాం సార్. అది పెట్టండి సార్. లైవ్
Hello, Vishnu. Yes, is my voice audible?
సార్ గుడ్ మార్నింగ్ సార్. ఆడిబుల్ సార్.
Good morning, Sridhar.
సార్ ఇక్కడ
సార్ ఆడిబుల్ సార్.
Okay, Vishnu. So 10 o'clock కదా start?
అవును సార్, అవును సార్.
Okay.
మీటింగ్ ఫర్ నో రౌండ్.
అది నాది మీట్లో పెట్టుకున్నా సార్, అది అందుకు ఒకే చోట ఉన్నందుకు అన్ని.
Okay, no problem.
ప్రెజెంట్ కదా. ఎక్కువ మంది ఉండని చూసుకోవాలి. అందరూ ఒకేసారి మాట్లాడితే స్టాక్ వస్తుంది. 2 సార్లు డబుల్ చెక్.
ఇప్పుడు యూట్యూబ్ లో ఎంతమంది జాయిన్ అయ్యారో తెలుస్తుందా?
శ్రీధర్ శ్రీధర్ యూట్యూబ్ లైవ్ కొత్తది పెట్టలేదు గ్రూప్లో. పెట్టలేదు చూసుకోవచ్చు. మళ్ళీ జాయిన్ అయితే
చదువు చేసి జాయిన్ కన్నా
ఇక్కడ అది వేరే ఏంటి
సార్ మీరు జాయిన్ అయినారా సార్? సార్ ఓకే సార్.
Vishnu, what about resource person?
సార్ 5 minutes చెప్పాడు సార్. 5 minutes జాయిన్ అవుతుందని చెప్పాడు సార్. ఆయన 5 minutes జాయిన్ అవుతుందని చెప్పాడు సార్. సార్
ఓకే.
ఓకే సార్.
మనం ఎప్పుడు స్టార్ట్ చేయాలని ఐడియా?
లేదు సార్, ఆయన కాల్ చేసాము 2 minutes అని చెప్పారు. ఆయన జాయిన్ అయిన వెంటనే ఇంకా మేడంకి చెప్పి పెట్టాము సార్, కిరణ్ మేడంకి.
అంతేలే.
ఎస్ ఎస్.
కావాలంటే ఇనాగరేషన్ అయిపోయినాక మళ్ళీ కావాలంటే కొంచెం 10 minutes అట్లా బ్రేక్ ఇచ్చేయచ్చు కదా.
ఓకే సార్, స్టార్ట్ చేస్తాం సార్. అయితే మేడంకి చెప్పేసి
అది మేలు కదా.
ఎస్ ఎస్ సార్. ఎస్ సార్.
ఎందుకంటే రిసోర్స్ పర్సన్ ఇంట్రొడక్షన్ అప్పుడు చదవచ్చు సెషన్ స్టార్ట్ అయ్యే ముందు.
ఎస్ ఎస్ ఎస్. మేడం కిరణ్మయ్ మేడం.
Hello.
Madam.
Sir.
Shall we start this session, madam?
Okay, sir.
Okay.
Good morning to one and all. Distinguished guests, respected principal, head of the department, esteemed faculty members, and dear participants, a very good morning. I be Kiranmayi, working as assistant professor in the department of ECS. On behalf of organizing committee, welcome you all this 5-day FDP the future of computing, emerging technologies and trends. Now, may I request Dr. R. Praveen Sam sir, Head of the ECS Department, to address us all.
Okay, thank you, Kiranmai. Good morning, all of you. I welcome you all to this 5-day faculty development program technologies and trends organized by our Department of Emerging Technologies in Computer Science. On this occasion, I would like to thank our Honorable Principal Sir, Dr. B. Srinivas Reddy Sir, for his continuous support in organizing this FDP, and I would also like to thank the management for providing the necessary resources without which this FDP would not be possible. At the outset, I would like to congratulate Dr. A. Vishnuvardhan Reddy, Associate Professor of ECS, Dr. K. Ashwak Ahmad, Assistant Professor of ECS, and Srimati O. Rupa Devi, Assistant Professor of ECS, and their organizing team in bringing out this 5-day online FDP from 8th to 12th July 2024. Technology today is evolving at a rapid pace, enabling faster change and progress, causing an acceleration of the rate of change. However, it is not only technology trends and emerging technologies that are evolving, but a lot more has also changed this year, making IT professionals realize that their role will not stay the same in the contactless world tomorrow. The main technological factors which are bringing the change, as we know, machine learning, data science, natural language processing, big data, and many more. These factors would revolutionize the way we live and work in future. In spite of busy schedule, all of you are all present here to gain the knowledge. I feel at the end of the 5-day FDP, all the participants would be gaining the knowledge on the future of computing, emerging technologies and trends that would be discussed in this FDP. Thank you one and all the best. Now I request Kiranmai to continue.
Thank you, sir. I would like to request one of the conveners, Dr. A. Vishnuvardhan Reddy, to give an overview of the FDP.
Thank you, madam. Good morning, distinguished guests, respected principal and head of the department, esteemed faculty members, and dear participants. On behalf of the organizing committee, it is my pleasure to extend a warm welcome to each one of you to this highly anticipated faculty development program, the future of computing, emerging technologies and trends. We are delighted to see such a huge turnout with 600 registrations, which reflects the enthusiasm and commitment of our academic community towards professional development. This FDP aims to explore the latest advancements and best practices in emerging areas of computer science, such as machine learning, deep learning, and big data, and thereby equipping us all with the invaluable knowledge and insights to enhance our teaching and research endeavors. Over the 5 days, we have carefully curated a diverse range of sessions and discussions led by esteemed resource persons and experts in their respective domains. I am pleased to introduce our distinguished resource persons who will be guiding us through this journey. Dr. T. Ramakrishnadu, Associate Professor, NIT Warangal; Dr. N. Srinivas Nayak, Assistant Professor, IIITDM, Kurnool; Dr. R. Jayakrishna, Senior Assistant Professor, Manipal Institute of Technology, Bangalore; M. Jahir Ahmad, Technology Lead, Samsung India; Dr. S. M. D. Muzib, Information Security Analyst, MEFE Tech; V. S. Chaitanya, Research Scholar at NITK, Surathkal; Y. Narsimhulu, Research Scholar, University of Hyderabad. Their expertise and experience are invaluable assets to this program, and we will remain grateful to them for sharing their knowledge with us. I would also like to extend our heartfelt gratitude to our principal, Dr. B. Srinivas Reddy Garu, and the head of the department, Dr. R. Praveen Garu, for gracing this occasion. The purpose of the learned faculty members here is to estimate to their dedication to continuous learning and professional growth. Your engagement in this FDP will undoubtedly contribute to its success and impact. The active participation and enthusiasm for all the participants is crucial to make this program a meaningful experience for everyone involved. We encourage you to take full advantage of the opportunities presented here to learn and collaborate with your peers. I once again extend a warm welcome to each one of you. Thank you for your presence and participation, and let us make the most of this opportunity. Thank you. All the best. And I would like to share you some points or parameters for issuing the certificates, like attendance and the quiz will be a mandatory one. After the once the FDP got completed, within 1 week of time, we will be issuing the certificates for the participants. And if you have any doubts during this session, you can share your doubts over the WhatsApp group, so that all your doubts will be addressed by the resource persons. With this, I would like to thank once again. All the best. Thank you, madam. Over to you, madam.
Thank you, sir. I deem it an honor to introduce the resource persons for today's session. Vinnakota Saran Chaitanya is currently pursuing his research studies in the Department of Computer Science and Engineering at the National Institute of Technology, Karnataka, Surathkal, under the guidance of Professor Dr. P. Santhi Tilakam. He completed his master's degree from the National Institute of Technology, Pondicherry in 2019 and his bachelor's degree from GPREC in 2016. Prior to joining as research scholar, he was associated with the department as an ad hoc faculty. He serves as a reviewer for the General Knowledge-Based Systems and Neural Computing and Applications and the ACM SIG KGT 2024 conference. His research interests including recommender systems, deep learning, and data analytics. I will hand over to the session in charge, Dr. Vishnuvardhan sir.
Thank you, madam. I request Saran Chaitanya Garu to take over the session.
Good morning, everyone. Good morning, everyone.
Yes, sir.
Good morning, sir.
Sir, am I audible and visible?
Yes, sir, audible.
Yes, audible.
Okay. Sir, I'm unable to share my screen.
Yes, sir. You are made as a presenter, sir. Yes, you can share your screen, sir.
Yes, sir. I'm sharing 1 second. Yes. Is it visible?
Yeah, yes.
Good morning, everyone. I would like to thank Dr. R. Praveen Sham sir for giving this opportunity, and I would like to congratulate all the participants who have enrolled for this workshop for the activity of knowledge gaining. And I thank Professor Kiran Mai for her kind introduction too. Yeah. On the outset, I'm very happy to be as a resource person for the FDP in my own college where I've studied. Thank you, Praveen Sham sir, for one more time for giving me this opportunity. Now, my talk today is entitled as Recommender Systems Tailoring Choices to Simplify Your Life. The word tailoring choices means it is removing or cutting off certain options for what? To simplify your life. Now we will see basically my talk today consists of 3 parts. Okay. first we will start off with the introduction. We will be analyzing in depth how the recommender systems fundamentals, like how the recommendations are generated and what are the present day constraints or the challenges to generate recommendation. And we will have a complete outlook or picture of the transformation of the traditional recommender systems to modern recommender systems. Yes. As I said, I am Vinakota Saran Chaitanya, research scholar in the Department of Computer Science at NITK Surathkal, under the esteemed guidance of Professor Dr. P. Shanti Telgamman. Vishnu sir, am I visible? Is my PPT
Yes, sir.
visible?
Yes, sir, yes. No, PPT was not shared. Only folder is visible, sir. You can choose the entire screen sharing option.
One second.
Yes, sir. Visible, sir.
Yeah, thank you, Vishnu sir. Now, outline of my talk is, first I will start off with the recommendation system, the traditional approaches, what are the limitations, what is the current day scenario, what industry is expecting. See, the main motto of this talk is, uh, I'm here to deliver a brief overview of the recommendation system. In one or two sessions, I cannot tell you entirely about recommender system and its functionalities, but I can assure you that at the end of the day, you will be having some takeaways so that you can go to your institute and conduct the research. Now, the first question is, why do we need a recommendation system? See, in this figure, I guess you will be seeing a lot many books. Suppose say this is a library of having multiple books. Assume that all are related to your domain. Okay. Now, you want to pick up a book to read. Whom do you ask? Anyone from the participant? Let's make the discussion interactive so that you will be gaining much amount of knowledge. Anyone? It will also ensure me that I am audible to you.
Audible, sir.
Yes. Now, in this scenario, if you have to take a book, you will ask a suggestion from a friend or a relative or some other person. Now, how does their recommendation depend? Their recommendation depends on their experience. Suppose say they might have read book A, but the features what he or she might liked in that book is not acceptable to you. Suppose say I've read only I want a textbook in the form of having examples, more kind of examples, and other person want a textbook in the form of concise theory. So these two things are different. Means what I'm emphasizing is the one which I recommend may not be apt to you. But what here we should see, it is a online Netflix platform. Let's assume there is a Netflix platform in which you want to see a movie. Now, Now, how do you select the movie? It all depends on the recommendation. But how do you generate a recommendation? That matters a lot. And now, coming to the history of introduction, history of recommender system, it was introduced by Salton et al. In the year 1978. The first model for the recommendation system was aimed at recommending documents. Okay. Now, as the year passes, as the decades pass, the applications of recommendation system can be seen in different applications. These are some of the applications. Netflix, where you will see movie recommendations, Spotify music recommendations, LinkedIn, and many e-commerce sites like Flipkart, Amazon, etc. And YouTube, these are the daily things where each and every user will come across. Now, initial goal of a recommendation system was generating accurate recommendations. What do you mean by accurate recommendation? Well, accurate recommendation in the sense means whatever user searches, only related to that we will be generating the recommendations. Now, if you take the difference between a search engine and a recommender system, it may be analogous to recommendation system or recommender system, both are same. Now, what does search engine does? When you give a search query, it will search large corpus and it will give the similar content to you. But how it is different with recommendation system? The recommendation system, it will consider your search keyword as well as your past history as well as the other user preferences and so on, which we'll be discussing in the course of time. Now, how recommendation system is generating the recommendations. It all depends on the user feedback. But how do we collect the feedback? It is also categorized into two types. One is implicit feedback and other is explicit feedback. Suppose say when you are using an application such as e-commerce application, you will be asked to rate a particular item or rate a recommendation out of 1 to 5 stars or in numericals or maybe scale of 1 to 10. There you will be providing some input, right? Okay, this input is known as the explicit form of rating. Next, there are three methods that generate recommendations using this explicit feedback. Those are content-based filtering, collaborative-based filtering, and hybrid filtering. These are the three traditional methods, and each method is having its own advantage and disadvantage. Next, as I said earlier, how do you give the input? The input is in the form of ratings, maybe numbers, say 1 to 5 scale. Now, in this PPT, you will be seeing an example where there are 5 users and 5 movies. And the users have rated different movies. Let's say U1 has rated movie 1 and movie 3. And user 3 has rated movie 3, movie 4, so on. The things, if you see, the blanks in the table is nothing but the user has not rated that particular item. Item in this case refers to a movie. it is feasible, right? We cannot rate each and every item. No. How does a content-based filtering generates recommendation? It will match the similarity between the items. What it will do, say some natural language processing technique it will be using, it will compute the text similarity between the description of items, and it will be recommending a similar item similar to the past rated item. Suppose say I have rated rated 5 out of 5 scale to green colored t-shirt. When it has to recommend t-shirts for me, in that scenario what it will be doing is it will take the description green colored t-shirt. Usually a description for an item such as movie or anything will be of 1 to 2 sentences. In this sentence, it will apply this NLP technique to find the similarity between the context, and thereby it will generate recommendation. Is it clear till now? Am I audible properly? Hello? Am I audible? Can someone please respond? Am I audible?
Sir, yes, sir.
Yeah, thank you. Now, we have seen the process of generating recommendation using content-based filtering. Now, what are the limitations that can be seen in this approach? Now, suppose say I have rated green color t-shirt 5 out of 5. Okay. Now, it is taking the that text of a particular t-shirt. This t-shirt is colorless. This t-shirt is of green color. Now, it will be recommending only green color items to me. It will be recommending only type of t-shirts to me. But I may be interested in purchasing shirts, or I may want to explore different items. So what can be done? These three are the potential limitations. Now, in this content-based filtering, there is one more drawback. Let's say I have rated for a t-shirt. Okay, it is recommending that particular t-shirt to the user. Suppose say there are some new items introduced into the database where you need to generate a recommendation. In that scenario, can that item be recommended? No, right? Why? Because no one has rated that a particular item, so that match cannot be drawn. Okay. Next. Now, what happens? This will limit the visibility of items to the user. Thereby, users will be dissatisfied on the application. Later, along with the accuracy, there are 3 more goals set for a recommendation system. They are diversity, novelty, and serendipity. What is diversity? What is diversity? It's about recommending diverse items to the user. What happens when we recommend diverse items to the user? the user can explore a lot of items. Suppose say in the corpus or in the database, there are some 100 items. Why should we recommend only certain type of item where there are 100 types of items? No. What happens in an e-commerce site? You will be viewing for a particular shirt. Okay. Particular, suppose a student who wants to attend interview is looking for a formal shirt. Okay. In his mind, he will be having a blue color full hands shirt he has to wear. Now he comes to e-commerce site and he will be searching for the same. But imagine or consider a scenario where the user will be getting an opportunity to view different colors of, say, dark brown colored shirt, which may look elegant more than that blue color shirt. So this increases the user satisfaction in on the application. No, diversity can be said as opposite to similarity. Okay, now in this case, if you ask me, sir, which is important, diversity or accuracy? We need to maintain a trade of both diversity and accuracy. Why? Why we need to maintain a trade-off? Because he or she wants to explore some item, your diversity should not irritate the user. Okay. Our recommendation should align with the user's preference. We should not completely go out of his aim or target what he wants to purchase in the e-commerce application. And novelty. The recommendation should be novel enough. What do you mean by novel? Newness must be there. Why there should be newness? Suppose say there are n number of mobile phones. Okay, from so long we are getting different types of mobile phones like Motorola, Samsung, LG, Nokia, and some even got extinct. Now the trend is iPhone 15, iPhone 16, whatever it might be. Still, if a user comes to the platform for searching Samsung Galaxy, now if you are showing a diverse recommendation, a diverse in the sense he is searching for Samsung phone, but you are showing Apple iPhone. Will that recommendation make happy or unhappy? Can anyone please respond? Will that recommendation make happy or unhappy? Obviously, it is happy, right? It will make the user happy. Why? He got a chance to explore more number of items. So we need to inculcate novelty in our recommendations also. Along with the novelty, there is one more constraint called serendipity. Now, here comes the challenge. Serendipity tells your recommendation must be surprising. Okay. Now, imagine you are searching for writing a DBMS table. Okay. Your YouTube recommendation will be showing dining tables. Will you be surprised? Will you be surprised? No, right? These kind of surprising recommendations should be relevant to the users. Okay. Incorporating these goals, the traditional recommendation had moved forward to collaborative based filtering. Now, what it will be doing in the collaborative based filtering is, it depends on the principle that users who have similar taste in the past will have similar taste in the future. What does this sentence imply? Suppose I, Saran Chaitanya, will be having a similar kind of purchase history of some other person X in the previous. Okay. Day before yesterday, we both have similar purchases. Now, yesterday I didn't make any purchase, but yesterday X has made a purchase. Now, what collaborative based filtering will do? It will see that in the past these both are having similar kind of what you call similar kind of purchases. Hence, hence Saran Chaitanya may also like the item K purchased by X yesterday. Now, this collaborative based filtering can be again classified into two types. One is user based collaborative filtering or item based collaborative based filtering. Now, in order to find a similar users, we have similarity metrics such as cosine similarity, Pearson similarity, and Jaccard similarity, and so on. Okay, now we will demonstrate the working procedure of collaborative filtering. One second. Yes. Now, imagine this is the user item matrix which consists of 5 users and 5 items. Okay, and the user has rated different items. Some as user 1 has rated I1 and I2 as 1, while I5 as 2. Similarly, user 4, if you take, he has rated I1 and I2 as 4 and I5 as 5. Now, how does collaborative based filtering will be generating recommendation? We shall see step by step. First, the metric used here is cosine similarity. Now, cosine similarity assume the items rated by the ratings of the items rated by every user as a vector. This cosine similarity will be finding dot product of the vectors. You suppose a cosine similarity between u comma v is u bar dot v bar by magnitude of u bar into v bar. What we have to do intuitively, we have to take the dot product. Suppose for user 1 and user 2, we need to take like 1 into 2. This is the item 1 rating by user 1, followed by item 1 rating by user 2. Similarly, item 2 rating by user 1 into item 2 rating by user 2, followed by item 3 rating by user 1 into item 3 rating by user 2. In this case, in this way, you have to do for all the items. This is for the numerator part, and for the denominator part, you will find the magnitude. Magnitude is nothing but the square root of all the ratings, and you will multiply them. For this, if you do 1 into 2 plus 1 into 0 plus 0 into 3 plus 0 into 2 plus 2 into 0. Okay. If you do, you will get 2 by root 6 into root 17. This is approximately 0.198. Similarly, cosine similarity of U1 and U3. Yes. Sir, I think participants have to join. Hello. Hello. No. Similarly, if you compute cosine similarity between user 1 and user 3, how do you do that? Again, 1 into 0 plus 1 into 0 plus 0 into 0 plus 0 into 0 plus 2 into 5 by square root of, and that gives you 0.817. In the similar fashion, U1, U4 it will give 0.974 and U1, U5 it will give 0.408. Now, the second step in the collaborative filtering is we need to compute the average of the rating for each user. Suppose for U1, 1 plus 1 plus 2. How much it is? 4 by 3. Well, that is 1.33. Similarly, average rating of U2 is 2.33, U3 is 5, U4 is 4.33, U5 is 1. Now, the third step is we need to separate the average rating respective average rating of a user from the ratings, those are non-zero. Suppose say 1.33 is the average for user U1, that you will be subtracting from item I1, I2 and I5. You should not touch I3 or I4. In that case, this subtraction is as shown in the slide. Now, the resultant matrix after performing the subtraction is minus 0.33 minus 0.33 0.67. Means you have seen a reduced matrix between 0 and 1. Now, imagine we need to generate recommendations to user 1. Okay, what collaborative based filtering will do is, first thing, it will identify similar users that we have done using cosine similarity function, and now we need to predict rating for the items, for the unrated items such as I3, I4. That's the third step. Now, how do we compute the rating for item I3? This cosine similarity for user. Now, if you see the cosine similarities between the users, U1 and U2 is 0.198817. Similarly, the highest similar user to user 1 is U4. And the similarity is 0.974. Since what we will be doing is, we will be taking the ratings of a particular user for that particular item. We will multiply it with similarity score. In this case, it's cosine similarity. Okay. Now, prediction for U1 on item 3. If you see, item 3 has been rated by only user 2. Okay. Now, if we multiply similarity score of U1, U5 with U5's rating on item 3, it will be 0. Similarly, it will be in all the cases. So, as the end result, we will be getting U1's predicted rating for item 3 is 0.198. Okay. Now, what is 0.198? Before normalized rating, it was 3. Okay. Similarly, if we see for item 4, we will be getting 2. Now, the predicted ratings for the item 3 is 3 and predicted rating for the item 4 is 4. Now, what happens? Which is highest? Item 4, right? No, sorry, item 3's predicted rating is higher compared to item 4's predicted rating. Now, when I am generating the recommendation, I will first project item 4 followed by item 3. Okay. Sir, as you said, we need to take a multiplication of similarity score as well as rating for a particular item. Here, there are 5 users, we can compute easily. But in the real-time scenario, there are n number of users, n number of items. What the recommendation system will do? This is the question. Now, what it will be doing? As I said earlier, in that case, it won't take the multiplication from every user on every item. We have a restriction, say K similar users. Suppose say out of 1000 users, we may take K as 100, means 10% of the total population, and we will take similarity between only these 100 users. What happens if we take similarity for all the users? One is computationally expensive and the other is we may not get the accurate result because every user may not be similar to each and every other user in particular. Now, there are some disadvantages of collaborative filtering too. What are those disadvantages? It will be recommending a particular item that is highly rated by other users. This I will discuss elaboratively in the further forthcoming slides. Next. If we see hybrid filtering, there are certain limitations for content-based filtering as well as there are some limitations for collaborative-based filtering. What hybrid filtering will do? It aims at taking the advantages of both systems and it will generate recommendations. It uses both content-based filtering and collaborative-based filtering. It will mitigate to a certain extent. Okay, issues of content-based and collaborative-based filtering. Now, we will discuss on the challenges by these traditional methods. The first one is static user item rating matrix. Now, if you see this matrix, an example, okay, U1 has rated item 1 as 1. Okay, this is very less rating. Now, what if user has changed his preference towards that particular item? We cannot accommodate that change because this matrix is ideally of static in nature. Next challenge is cold start. As I've said, cold start is nothing but for a newly entered item or user, collaborative based filtering method cannot generate recommendations. Because in the user item rating matrix, entire row for that particular user will be 0. In that case, how do you find the similarity? Similarity computation is not possible because you will, if you see this step, numerator will be 0 as the new user didn't rate any item, followed by the magnitude. Root 0 square will be 0. 0 into something will be 0. 0 by 0 is an infinite undetermined state. So, collaborative based filtering method fail in this. Now, what is the gray shift problem? See, what collaborative based filtering is ideally doing, it is computing similarity with the other users, it is recommending. Now, suppose a particular user is having unique likes or unique preferences or unique taste. In that case, it is very difficult for the recommendation model to generate appropriate recommendations in order to satisfy users' requirement. This can be seen in this example. See, we got highest similarity between user 1 and user 4. Okay, but let's see the matrix. Now, user 1 has rated very low for item 1 and item 2. 1. Okay, for item 5 also, user has rated very low, that is 2. Coming to user 4, we can observe that user 4 has rated both item 1 and item 2 as 4 and item 5 as 5. Means this user 4 has pretty much liked the item 1, item 2 and item 5. Whereas user 1 has a strong dislike over item 1 and item 2 while dislike on item 5. Now, what do you interpret? This cosine similarity is telling they both are similar users. But if you see their rating or if you analyze their rating, it is not reflecting. This is one major concern for the collaborative based filtering. Now, filter bubble. What it will do, filter bubble? See, here again, in collaborative based filtering, it will be recommending items where more number of users has rated. In that case, only popular items will be recommended. So, user visibility is again limited because we are recommending only a set of items. Now, user visibility is again limited in this collaborative based filtering due to filter bubble issue. Now, long tail. What do you mean by long tail? The items that do not have enough rating will not be recommended by collaborative filtering approaches. Why it happens? Because an item is having a rating 1 among a large corpus of 1000, 10,000 items. Okay. What will happen here? Item having rating 1 will never be recommended because it will always recommend items having higher ratings. No. Shilling attack. What do you mean by shilling attack? Anyone? Yes, am I audible? Am I audible? No. Shilling attack here is in order to generate a proper recommendation, what we'll be doing? We need to have rating for that item. Now, if we introduce fake ratings for an item, it will get populated so that it is generated as a recommendation. Yes or no? Yes. This happens and this is known as shilling attack. Now, skewed recommendation. You might have heard the word skewed. Left skew, right skew. Okay. Now, collaborative filtering will lie towards popular items. Here, I do not mean left side or right side, left skew or right skew, but I mean to say that this will recommend only popular items. Again, data sparsity. Now, let's go back to the matrix. If you see the number of ratings here, it is a 5 by 5 matrix. 20 means 25 entries must be 25 entries must be there. But if we see the number of non-zeros, 1, 2, 3, 4, 5, 6, 7, 10, 11 means 11 out of 25. It's not even 50%. Now, when you are taking data and when you are training your machine learning or deep learning model on this amount of sparse data, will you be able to generate proper recommendation? Will you be able to generate proper recommendation? Absolutely no. Why? Because data is insufficient or inaccurate. So the prediction results may not be always true. Now, with these challenges, later a new type of recommendation that is based on implicit feedback has come into existence that we will be seeing in our second part of the discussion. Now, what do you mean by implicit feedback? As we have discussed earlier while seeing the matrix, we came to know that there are n number of users and n number of items, say m users in items. We can form an m by n matrix. Sir, am I audible? Sir, anyone please respond?
Yes, sir, audible.
Thank you, ma'am. Now, rating each and every item for a user is not possible because of massive number of items coming in day-to-day life. If you see Amazon or Flipkart, any kind of e-commerce platform, there will be millions of items arriving on every single day. As a human being, is it possible to rate each and every item or leave about all n items? Let's take, we have interacted 100 items where 100 is very much smaller compared to n. Okay. Is it possible? No. Definitely no. It's not possible for a user to rate each and every item. So, we came up with the implicit feedback driven approaches. What do you mean by implicit feedback? A feedback collected as a user behavior without its interference. User will not be generating the user will not be giving the feedback directly. Now, how do we get that? We get by catching the session data. Again here, question arises. What is a session? A session is a logical time period. A session is a logical time period. Suppose say you establish a connection. I'm not talking about TCP/IP or something, three-way handshake or something. Now you start a session of browsing on an e-commerce website till say 30 minutes, usually till the end of the session or till some time limit. There will that time period is known as session, and the activities you perform during that logical time period is known as interactions. What you will be doing there? You will be performing some interactions, which is also known as session interactions. This will be recorded as a session data. An ideal session data mandatorily consists of session ID. No, not even session ID. Some data set you will be having without session ID also. You will be having item ID and the timestamp. Timestamp of what? Timestamp of the item, time of interaction of that particular item. If you see the following figure, it is a snippet taken from the YouTube's dataset, which is released as part of RICS 2015 challenge. The fields are session ID, timestamp, item ID, price, and quantity. Now, you have taken this session data. How we will be generating recommendations? Let's see. Now, this in the implicit feedback will, if we construct a user item matrix, it will be a Boolean matrix. Why I am saying Boolean? What do you mean by Boolean? 0 or 1, right? No, wherever or to whichever item you have interacted, it will be marked as 1. Other will be marked as 0. Now, I am having 0, 1 matrix, say some m by n matrix with the m rows and n columns. Now, what I will do, I will be taking that each row of your interactions of your session. Suppose say a user 1 has done 1000 sessions. Let's say for your past 6 months or past 1 year, you entered Amazon site and you made some 100 purchases. Okay, 100 sessions you made. So the user item session interaction matrix will be having 100 rows. Fine. Now, what you will be doing? What a recommendation model will be doing? It will take those data, it will analyze. Again, for analyzing, there are certain parameters that we will be discussing. Now, this analysis is known as session-based recommender system. It produces recommendations by analyzing the session data. Now, if you see here, you are having session ID, timestamp, item ID, price, and quantity. But you are not having user details. When user details will be available? Only when the user logs into the application. So in that scenario, if the session data also includes user information, then on that kind of data you are generating recommendation. It is known as session aware recommender system. What this session based or session aware will do? It will employ correlation among the session interactions to understand the user preferences. This word is very, very most important. Understand, we need to first understand the preference of the user and we need to generate the recommendation. Now, we can classify a session into 3 types. One is short length session, a medium length session, long length session. A short length session ideally consists of less than 5 interactions. Suppose on an e-commerce site you made less than 5 interactions, then it is short length. Medium length, it will be between 5 and 10, and if you are having an interactions more than 10, it is a long length session. Now, what happens in short length and medium length? You will be having a very few interactions. Okay, and interaction in the sense, we will talk in detail later. This kind of interactions you will be having. Of course, I've shown it pictorially. In the database, we will be recording the item ID, followed by you will be having description of items in the other table. Okay, these kind of interactions will be. So in this, what happens? You cannot accurately identify for what user is looking in both short and medium. While coming to long length session, suppose say you have made so many interactions. What is the actual intention of a user coming to e-commerce platform? That cannot be adjudged. That cannot be assessed. What happens when you cannot, when you do not assess it? You cannot generate the appropriate recommendation. Okay, what happens in long length session? And see, I have free time for 1 hour. I do not have any other work. Okay, I will be browsing Amazon website. What I will be doing? I will be clicking on each and every item. So, how does the SBRS or SARS will be able to identify that what Sharon is looking for. That cannot be analyzed, right? So that is the problem for with the long length session. Why in between I might have made some interactions that are not potentially important, but it affects the decision making process of a recommendation model that we'll be looking upon. And you can ask me, sir, whether noisy interactions are present in short length and medium length. Obviously, yes. It may also have a noisy interaction, but the probability will be less. If a user is making less than 5 interaction or 5 to 10 interaction, mostly user will be clicking on the items on what he is interested upon. Okay, but there is a chance of existence of noisy interaction in all the 3 types, majorly in long length session. Now, what we'll be doing is, we'll be understanding how, or we'll be interpreting on how the SBRS or SARS will be understanding the user preferences. One approach is consideration of users' historical preferences. Let's say, first, see here, when I'm talking about long-term preferences, I meant to say session-aware recommender system. Means I know the user. By knowing the user, what I will be getting? The previous records or the history of the user. Now, see, if I see the first interaction, it is of yellow color collarless t-shirt. Okay, now as a recommendation model, I will be understanding that user want to purchase a collarless t-shirt, probably of yellow color. Now, what I will be generating? Recommendations similar to that sort. Now, let's see the second. The user has again clicked one more t-shirt. Now, there is a color variation, but type is same. So, recommender system will, SARS or SBRS will make their mind as user want to purchase a collarless t-shirt. Now, again with third interaction, it is firmly affirmed. But if you see these 3 interactions are of different colors. One is yellow, one is light green or thicker green, and the other is light green. Now, the recommendation model will be confused. After 4th interaction also, it will be pretty much confused on the color user wants to buy. Suppose, if we see the purchase history of the user, we can see that user has purchased white color collarless t-shirt as well as black color collarless t-shirt as well as white color shirt. Now, with current interactions, we purchase a collarless t-shirt. But if 2 interactions are related to white color, so recommendation model can understand that user is interested towards purchasing a white color t-shirt and it will generate recommendation. But diversity is also needed, right? Because in the current searches, there is no white color. Okay, but as per the long-term preferences, we understood that there might be a probability for purchasing white color. But if we see the current interactions, we do not see any sort of that idea with the user. Now, what we can understand, user may tend to change their preference also. Okay, so our SARS or into tool SARS, our SARS will be recommending a white color t-shirts along with the different colors. Next, similar set of interactions, but a different user history. Now, the current mood of the user is to purchase a collarless t-shirt, but recommendation model is confused in generating, confused to it want to know what color user might like. In order to know that, it has searched the past history of the user and there is no interaction related to t-shirt. In that scenario, can we understand the user preference from long term? No, absolutely no. Even though it is session aware recommender system, it all depends on the current interaction system. Okay, we need not account for the long-term preferences. There is no use. Okay, sometimes it happens, but there is a study saying that 98% of users get satisfied with the recommendation based on the past preferences. But we need, it is our job even to consider and make happy the remaining 2%. Now, there is a second parameter known as sequential visualization of clicks. Now, how recommendation model came to an assertion that user wants to purchase a collarless t-shirt? By sequentially analyzing the clicks. Here 4 clicks are there. The first click is of t-shirt, second click is of t-shirt, third is the same and the fourth 2. By sequentially viewing all the 4 interactions, the SARS or SBRS came to know that user wants to purchase a collarless t-shirt. Color you keep it aside, but at least we came to know the intention of the user. Now, tell me the user intention here. If you see, the first interaction is of yellow collarless t-shirt, followed by a notebook, followed by a dining table, followed by a mobile phone, and the end shoe. Now, in this situation, can sequential visualization of clicks help the recommendation model? Answer is absolutely no. Absolutely no. Because one is related to clothing item, one is related to what you call notebooks, and the other is furniture item and the mobile accessory, and the other is wearable. So it is you cannot always judge what a user wants. Now, what happens if we mix both sequential visualization as well as long-term preferences? It will be similar to this way. Okay. Sequentially, we will be knowing that user wants to purchase a t-shirt, suppose a collarless t-shirt. Let's say we ideally have a history of yellow color t-shirts. Imagine user has earlier purchased in the previous session yellow color collarless t-shirt. Intuitively, the recommendation model can generate some recommendation of t-shirts with yellow color. So this is one advantage. But see here one, there exists one more case here. Now, first three interactions, you need to analyze what recommendation model will be thinking after every click. Okay, after first click, the recommendation model wants understood that user wants a t-shirt. Okay, this is firmly accepted with three interactions, while fourth interaction is related to shoe. Now, there are two possibilities. One is user mindset has changed. This is one option. Okay. And the other option is user might have clicked it without the intention, means a noisy interaction. So two cases are there. Which case we have to consider? First case, if we consider, if we think user preference has changed, we do not have any evidence. See, three interactions are related to t-shirts, while a single interaction is related to shoe. So it is not possible to firmly ascertain that user current preference is on viewing a shoe item. Okay? No. In that case, can we imagine as a shoe as a noise? As of now, we are imagining shoe as noise, but again I am emphasizing this assertion need not to be true always. No, does the user click shoe interaction unintentionally? This is the question, and we'll try to answer this soon. We have one more parameter known as dwell time. The amount of time spent by user in viewing a particular item is known as dwell time. Means how much time a user is viewing a particular item. How do we get it? Sir, in the data set what you have shown as a snippet, it do not consist of dwell time. Yes. Dwell time will not be shown directly. We need to compute the dwell time. Suppose say during the session ID 420374, the user has clicked the item ID 214537 at this following time. Okay, 1844:58. Imagine the next item clicked is 50 within 58, means user not even spent any time there. But if you see like instead of 44:58, if you see 45:38, there you can understand like user has spent around 40 seconds in viewing that particular item. Okay, through that you will be able to compute dwell time. Now, assume these are dwell times for those particular items. Now, if you see t-shirts, each t-shirt user has been viewing for at least 25 plus seconds. Okay, and it's 28, 30, 30. Let's take 25 plus seconds. Now, in this case, what is happening? If you see the shoe interaction, user has clicked only for 3 seconds. Only for 3 seconds. What we can analyze? User is more interested towards t-shirt rather than shoe interaction. Why I am stating that? Because the time spent by the user viewing a t-shirt is much greater than shoe interaction. Much greater means it's a relative comparison. Don't take as 35 seconds is a much greater time. Okay. And for a last interaction in a session, we do not have dwell time. Why? To compute dwell time, we need to have consecutive start timestamp, right? Which is not possible. So the dwell time for the last interaction is taken as 0. Now, what I have said, shoe interaction is having less dwell time compared to t-shirt. But why? Again, there might be two cases. While weaving a t-shirt, let's imagine I am making these interactions, these first 4 interactions. First, I have clicked t-shirt 1 and I was talking with someone. After 35 seconds, I clicked one other interaction. Again, I continued talking. And t-shirt 3, again I did the same thing. After 28 seconds, I visited shoe item. Now, in this case, can you firmly say that I came to the platform for shoe? No, it is not possible. So, the reason for longer dwell time may be user might move away from the system. Okay, leave about longer dwell time. For shorter dwell time, we can have one more counter reason. Okay, now I want to purchase a t-shirt. I don't know what color I want to purchase, but firmly I need to have a black color formal shoe. Okay, in this case, I need to verify different t-shirts. Okay, which might be better, in which I look good if I wear that particular t-shirt. For that, I need some time to analyze. But my aim is to purchase a black color formal shoe. Then why do I see a white color informal or sports shoe? But your reason or your assertion in the sense assertion made by the SBRS or SARS is going to be false. What we have said, shoe interaction was unintentional. So this cannot be determined. Okay. No. Okay. Through what I'm saying, through sequential analysis, I'm unable to determine user preferences, ongoing preferences, or through history, I'm unable to generate recommendation, or by considering dwell time, I'm unable to generate recommendation. Now, let's see about the other parameter, consideration of neighbor sessions. Now, let's take a 2-minute break here. I'll come back.
Hello? Hello?
Hello.
Yeah.
Yeah, sorry for the interruption. Now, if we take the next parameter, that is the consideration of neighboring session. What do you mean by neighboring session? Neighboring session is like a parallel session. Means at this point of time, on 8th July 11:30 a.m., I am browsing a session. At the same time, on 8th July 11:30 a.m., some more users, other users might be browsing the site. So these are considered as a neighboring or parallel session. Usually we call neighbor session or parallel session. Now, what is the advantage by taking neighboring sessions or parallel session? We shall see. If you see, user one session on a news platform, he is reading about Virat Kohli. Okay. For first news item, since it was a news item, he has taken 240 seconds, ideally 4 minutes for one particular news article. And the other article also, the user has taken 75 seconds. Okay. Now, parallelly, if you look, there is one more session happening by user N. Okay, same. The user has been reading same kind of news, Virat a game changer, and the special edition about Virat Kohli. Now, subsequently, in the subsequent interaction of user N, it is uh, headed as Return of the King. Since the user N has similar interaction with the user 1, okay, there is a high probability that user 1 will be reading a news article entitled Return of the King in the subsequent interaction. This is what we can understand. Okay. But we cannot assure anything. Why I am telling that we cannot assure anything? Because after reading 2 news articles on Virat Kohli, user interest or user mood might have changed, or he might have completely understood about the points about the Virat Kohli, about the current strategies, what is employing, or the current strike rate, or how he is performing and all, blah blah blah. He might have understood. So there is no necessity to read one more news article. So here also comes with advantage followed by a disadvantage. That's what I'm trying to explain with each and every parameter. Now, again, if you take a neighboring session, there might be users with unique preferences. Again, it might tend to Gray-Sheaf filter bubble kind of issues. It is not always possible to compare with the neighboring sessions. Now, one more thing. When you are purchasing or when you are looking some item on an e-commerce site to purchase, imagine you are looking for shoe item here. Okay. In between, an interaction of mobile came. What do you understand from the previous discussion? Due to less similarity between the items, you might be understanding that mobile item is a noise. But imagine that it was a popular item. Popular item in the sense, for a user, say 7, I am browsing that. My friends, Sam or Joe or some X or some Y has purchased a new mobile. Now, I too want to explore it. That's why I'm clicking on it. Now, how can you consider the mobile interaction as a noise, and how can you give me shoe item alone as a recommendation? It is not feasible. It is not correct. So, user mood may change abruptly. As you said, this might be a noise as well as this might be user's intention, actual intention. Okay, now one more case here. Through these parameters, what you have understood, anyone please talk for a while so that I will be happy. I can expect at least that you are listening to my session. Please, any one of you. Vishnu sir. Okay, moving ahead. Now, what I want to tell you here is determining user particular intention at that point of time is pretty much difficult. You may be having n number of parameters, say sequential analysis. You may be considering long-term preferences. You may be considering dwell time. You may be considering popular items. It is pretty much difficult to understand the user preferences. Now, one more parameter is coming up that is known as contextual factors. What do you mean by a contextual factors? Contextual factors which include some preferences such as demographics. It will take consideration into demographics, gender, age, sex, and seasonal information. Now, let's say in a country, country like India, if a user is browsing an e-commerce site during October or November, okay, October or November is Diwali time, right? Diwali is celebrated, of course, worldwide and mostly in India, and most of the North Indians and we also South Indians celebrate it in large scale. Okay. Now, what will be ideally purchasing during that time? We will be purchasing Diwali diyas, lights to decorate around the house. Okay. Now, in that scenario, if our recommendation model may generate one recommendation, may not be after user interaction, may generate when the user has logged into the site. And if we see the Dias as a recommendation, there is a high probability that due to Diwali season, the user might purchase. Okay. And specifically, if we show jerkins during winter season, especially for the regions like North India or Northeast, it is having a huge impact or huge probability of users purchasing those jerkins. Now again, controversy exists. Not every user may purchase. Suppose for Diwali Diyas, persons from other religion may not celebrate it and may not purchase. So, what is the summary of this? Understanding user preferences and accurately generating recommendation from vast array of available items that match user preference is not easy. Now, till the discussion happened till now, what I want to emphasize is this job of recommendation is not so easy because of one thing. User preferences, most of the times, it won't be pretty clear. Second reason, what you can say, user preferences may vary over time, or user interactions might be noisy. And even though even though the recommendation model has understood what user is looking for, among the vast pool of items, it is not feasible to recommend few items. Ideally, what we'll be seeing as a recommendation on the screen, we'll be seeing, if it is a desktop device, we'll be seeing 10 to 15 recommendations at the max. If it is a mobile, we'll be seeing 5 to 10 items at the max. But we are having n number of items. If you take a t-shirt, there are m types of t-shirts and n number of t-shirts of different colors, different shades. Out of that, how do you recommend? How do you pick those 5 items? Say NC5, it is a challenging task. And one more challenge is user interest drift. What do you mean by a drift? Drift is nothing but change. What change? Change in user interest. It is known as user interest drift. And user interest drift or UID can occur multiple times in a session and can occur multiple times. Okay, take this example. If we see here, first interaction is of t-shirt and the other interaction is of second interaction is related to notebook. If we compare, there is a change in preference from clothing item to accessories item. Okay, again, notebook to dining table, furniture item. Now, clothing to accessories, essentials of a college going student. From these essentials of college going student to furniture item or mobile accessories, you can see shift in multiple times. And this shift is known as user interest drift. Okay. Now, what is the challenge here to understand that? The challenge here is you need to be able to differentiate between a noise and an intentional interaction. Okay. Noise and intentional interaction. And it is difficult due to the presence of noisy interaction, and this can be divided into 5 types. Sudden drift means there is a sudden change in the category of the item. Gradual drift, incremental drift. Both are related to a slow change. In the incremental drift, the underlying pattern also changes. If you see the blip drift and the other is the recurrent drift. If we talk about blip, this change will be temporary. See, user has clicked 3 t-shirts, went to shoes. Within a short period of time, the user preference has been regained to t-shirt. Okay. In this case, the shoe preference came after third interaction, that is nearly around 1 minute 33 seconds. It stayed for 3 seconds and the user preference has been shifted to t-shirt again. In this case, it is known as a blip drift. No. And the last one is recurrent user interest drift. This I will be discussing in detail. Okay, now UID identification is challenging. Suppose a SBRS is generating recommendation for an anonymous user. These are the following interactions. Till the third interaction of the first figure, we can understand that user is interested in viewing college going items, and the fourth interaction is also related to that. Somehow it can generate a recommendation, but the second part is a bit difficult. Notebook, furniture, followed by textbooks, followed by a furniture. Now, if we see that dwell time is also almost similar, so we do not have any, we cannot say like this dining table interaction is of noise. We cannot accurately say that statement. So it is a bit difficult and challenging to identify user interested drift. Now take this example. Sorry. First interaction is related to shoe item. Okay. And the second interaction is related to shoe item. Now, followed by third interaction is related to shoe item. Till this third interaction, our SBRS will come to know that user wants to purchase or view a shoe. Okay. Leave about the color. Color is immaterial in this discussion. No. The fourth interaction is related to mobile. See, there is no relation between shoe item as well as mobile accessory. Sorry. And if you see the dwell time of shoe, it is around 55 seconds plus. Now, mobile dwell time is 21 seconds. Now, you cannot accurately say mobile is not noise. So, there is high probability for saying mobile as a noise. And if you see the fifth interaction, it is related to shoe, means which you can ideally say that user by mistakenly had clicked the mobile item and came back to shoe item. Okay. This is affirmed with the sixth interaction too. Now, this is what SBRS understanding is. But if you see the pattern from third interaction to fourth interaction, there is a change in user preference. And this change got disappeared from 4th to 6th interaction. Okay, this change during 5th interaction, the user has regained the previous preference or obtained a new preference, that is immaterial. He has viewed a show. Okay, but the change got disappeared during this period of time, and user has that preference has reappeared. Change got disappeared but reappeared. Okay, and this is known as recurrent user interested drift. Okay, this style of change in user preference and followed by its disappearance and reappearance is known as recurrent user interested drift. And this recurrent user interested drift also resembles as noise. Means what? As per our analysis during 4th interaction, the mobile interaction was a noise. So this recurrent user interest drift appears to be noise, and this kind of user interest drift or UID is common in the real-time platforms. Means real-time platforms in the in your Amazon, Flipkart, these kind of interactions may repeatedly happen, or this kind of behavior can be observed from different users. Now, in order to generate successful recommendation, we need to, it is mandatory to understand the user preference. So we need to identify recurrent user interest drift. But unfortunately, there is no work related to recurrent user interest drift in the literature, which we have addressed the issue, but that problem or that solution is still in progress stage. Like we have communicated to journal, so till we get so till it get published, I cannot disclose the solution of it. Now, based on the current discussion, you may get one more doubt. Sir, on Amazon e-commerce site, I have browsed for a new watch. Okay. Some type of X type of watch, and I have left that search. I got some other work and I got into some other site, some other application. No, but it is showing advertisement related to that particular watch item. How does it showing? Is that using a recommendation algorithm or something? No, it's not a recommendation basically. It is known as ad retargeting. Means, what do you mean by ad retargeting? It aims to convert your interest to purchase. See, you are viewing a watch item of some company. It will repeatedly show this ad. What you will do? It will intricate, or it will put pressure on your interest. It will make you buy. Okay, this is a bit advantageous to not the user. It is advantageous to product owner, because it's ideally making your interest as a purchase. What it will take? It will take the data obtained from cookies. So it's ad retargeting is not similar to session-based recommendation. When I take the word session-based recommendation, it includes both session-based recommender system as well as session-aware recommender system. It will also, SBR also uses session data, but it tries to generate personalized recommendations. What do you mean by personalized? Based on the user's preferences. And it will take the data of that site alone. Now, we have seen this, how session-based or session-aware generates the recommendations. Now, when we talk how deep learning is useful for recommendation system, or particularly for session recommendation system, we very well knew that there are a lot of attractive features related to deep learning. Like when you have a large data, very vast data, deep learning techniques will be able to identify the patterns among the data. It will have multiple levels of representation and abstraction. It can handle the complex data, and these are pretty much known for sequential modeling, which ideally our SBRS and SARS do. As I said, as the amount of data increases, the performance of the deep learning model increases, while the older learning algorithms like machine learning algorithms is not be very much suitable. And in the machine learning algorithms, we need to supply the features manually. And there are different deep learning models such as multi-layer perceptron, MLP, autoencoder, convolution neural network, recurrent neural network, attentional model, deep reinforcement learning, graph neural network. And see, each deep learning model is having their own purpose. If you take autoencoder, what is the use? It will reconstruct the image from lower dimension to the original dimension. If you take convolutional neural network, it is used to identify the image. Okay, this image forms the input to the CNN model. Recurrent neural network, as you know, RNN models are very famous for sequential learning, which is very much essential to us. Attentional model, what it will be doing? Out of the entire session, suppose say any interactions are there. If we use attentional model, it will give the accurate weight setting for a particular item. In deep reinforcement learning, what it will be doing? This will continuously improvise the model. Reinforcement learning, what it will do? It will continuously improvise the model, fine tune by learning from the mistakes, where the model will be penalized for the wrong action and it will learn through the mistake. And the graph neural network, as you already know, we can construct a graph like suppose say items. And items will be the different nodes and edge between the item, between two items. Maybe you can take number of interactions for two items together. Like in a session, if you click I1, I2, okay, you can see in your data set how many I1, I2 interactions are there. Suppose say in a data set is having 1 lakh interactions, simultaneously how many I1, I2 clicks are there. If you say some 50 or 30,000, you may weight the edge as 30,000. Or you may have some kind of representation. You may have dwell time as the edge weight, or you may have it may not be sequential, or it may not be the in the immediate sequence also. You may take depending on your requirement. See, it is not possible for me to tell the exact advantages of deep learning models here. Okay, I'm just giving an introduction so that you will be knowing why a particular model is used. Now, does any one of you worked with image processing? Any one of you? Does any one of you worked with image processing? Yes. We got a response like some have worked on it. But suppose say you are aiming at object detection or some tumor detection. Now, you will be having a train set as well as test set. Now, your model will be predicting whether tumor is there or not. But how do you compare whether it is right or wrong? Or object detection or some satellite images you will be working on. Now, there you will be having ground truth. What do you mean by ground truth? The actual spots. If it is like a tumor detection, you need to have set of, see, you will give your model some n images, it will identify the tumor. Okay, when you give it, when you give a sample image, it will identify tumor, it will round up. You will be having a ground truth for the following data set, for the following input. Okay, this image should show a particular plot at this point. But in our recommendation model, we do not have such kinds of ground truth. Now, how need to, in that scenario, how do we need to analyze the data? We need to know which interaction is correct, which recommendation is correct. How we can do that? So, suppose say we have clicked C1, C2, C3, C4, C5. 5 interactions we are having. We will train the model in such a way that one click gives the other. C1, C2 gives, sorry, C1 gives C2, C1, C2 together gives C3, means multiple permutation. C1, C2, C3 gives C4, C1, C2, C3, C4 gives C5. What does it tell to deep learning model? Means when there is a click on item C1, you need to generate a recommendation of C2. Okay. When the user immediately clicks both C1 and C2, you need to generate a recommendation of C3. Similarly, for C4, C5. In this way, we are judging the model whether it has given interpretation, whether it has given recommendation correctly or not. Sorry. No. This is the first work that we have used deep learning for session-based recommendation. Okay. It was by Hidasi et al. And the title of the paper is Session-Based Recommendation with Recurrent Neural Network. It is a simple model. Since it is the first model, they were able to publish the paper. Straight away RNN model, they have passed interactions and they have computed, they have generated recommendation. Okay. And this is the first work that incorporate dwell time along with the session interaction. The work by Bogina et al. Okay. What they have done, they have taken this dwell time as a separate input. Okay, dwell time of all the interactions as a separate input along with the session interaction, and they have passed to the model. It have used the same model proposed by Hidasi et al. It is known as GPREC for RICA. Now, this is my work that I have used contextual factors. I, along with my guide and one more MTech student, have worked on this user interest drift identification using contextual factors in implicit feedback based recommender system. See, we aim to capture user interest drift using the contextual factors. I'll be explaining about the model. In implicit feedback based recommender system means we have considered both session based as well as session aware. Now, how we have done that? Now, the inputs such as the interaction IDs, item IDs, as well as dwell time, we have passed to we have taken as an inter-session context, intra-session context, and we have passed it to GRU layer, where GRU layer will analyze it sequentially, and it will give its intermediate output to delta intra, where we have used the fully connected layer. Means all the neurons of one particular layer is connected to each and every other neuron of the next layer. As simultaneously, we have taken inter-session context, that is the session ID, and the session length. Session length we have computed by computing the sum of individual del times and the month, day, hours, minutes, seconds, and number of item views. This we have given as an inter-session context. This we have passed to convolutional neural layer. Why we have passed to convolutional neural network? See, in the image, how we will represent an image? In the form of pixels. Okay. What this CNN will do, CNN will take the surrounding pixel information also. Means usually when you talk in recommender system, everyone will work with the text data alone, text data or numeric ratings, so on. But what we have done is we have converted the entire information into an image. We have passed into CNN so that it will give the intermediate input to delta inter, which we have combined with the softmax, which we have passed to softmax layer, and we have predicted the probabilities of items. And one more thing you need to remember is, here we will give the probabilities of items. Okay, and depending on the number of items to be recommended, okay, suppose say we need to recommend 10 items or 20 items. So items having those top 10 predicted probabilities or top 20 predicted probabilities will be generated as recommendation. That's why the output of the final softmax layer is predictions probabilities. Okay, predicted probabilities of items. Now, what are the limitations of session based or session aware? Okay, the session based recommender system or the session aware recommender system is built statically. What do you mean by static? We'll take a data, okay, we'll train it offline. When a new data arrives, the model will take the data, okay, based on the knowledge which I learned in the offline or earlier, and it will generate recommendations. But what is happening in the fast changing world? The data is numerous. It will arrive in the form of a click stream. Again, what do you mean by a click stream? Session data together as a bunch. It is known as a click stream. So these all are coming as an input to our model. But we need to judge whether our model is capable of taking that huge amount of data. That too simultaneously. We have discussed about the user intercept, how the model will automatically learn from the data. Massively, it arrives with a huge volume. Huge data is coming with a high velocity. How does the model learn? These static models are not sufficient, because we need to rebuild the model periodically. Whenever data comes, we need to retrain the model in the offline. But it is computationally very much expensive. So what we have to do? We came up with streaming session-based recommender system that we'll be seeing in a course of time. Before that, we have to know about different data sets and the evaluation metrics. If you consider data sets for session aware or session based, we have choose dataset, e-commerce one, last FM, music data, Govala, location based, Tmall again is e-commerce dataset, 30 music dataset, movie lens and Netflix consists of movies things. And how do we evaluate our recommendation model? Using recall, MRR, precision, NDCG, accuracy, F1 score. If you see recall, it will see how many relevant items are related or recommended. MRR, it will see the rank, and the precision is like how much amount of relevant items are recommended. Similarly with accuracy, and F measure is an harmonic mean of recall and MRR. Now, what happens in real-time scenario? This I have discussed. Data arrives in the form of large volumes as an unbounded flow of temporally ordered click stream. What do you mean by unbounded flow? Unbounded flow means the data will not be having a particular start and stop point. Continuously your model will be receiving the data, and the data will come at irregular intervals. Means at this point of time it has come. It will come after 5 minutes. There is no such intervals for that data. At irregular interval, it will come with high velocity. Now imagine in this scenario, you need to identify user interest drift or recurrent user interest drift and generate recommendation. How much difficult it is. It is not feasible. That's why we are moving to streaming session-based recommender system. It is an enhancement of session recommender system. Means it will consider dynamic data. It will retrain among itself. As a multiple chunks it will retrain. It will be ready for the online data. Okay. But the problem with the neural model is catastrophic forgetting. What do you mean by catastrophic forgetting? What do you mean by a forgetting? As a human being, we can remember some things to a certain extent. Okay. Neural model is far ahead to our memory. Okay. I accept. They can remember to a certain extent. But this large volume of data, can they remember? No. This situation is known as catastrophic forgetting. What happens in the catastrophic forgetting? Basically, what model will learn? See, if there is a click of blue color t-shirt, there will be an immediate interaction of black color pant. Let's say most users behavior is this: a blue color shirt followed by black color pant. Now our recommendation model has to remember this pattern in order to generate a recommendation of black color pant when a user clicks blue color shirt. If the recommendation model forgets it, how does it generate a recommendation? In that scenario, that recommendation is not accurate. So, This situation is known as catastrophic forgetting. In order to avoid catastrophic forgetting, we need to store some amount of data, and that storage is given by a reservoir. What do you mean by a reservoir? A reservoir is a storage space inside the main memory. Okay. Now, do you think inside the main memory of the model how much our processors, how much our generations have evolved? Do you think this much vast amount of data can be stored? No, it's not feasible because reservoir is a small storage space inside a main memory. Again, the discretion comes what to be stored and what not to be stored. Now, we will see the workflow of the streaming session-based recommender system. See, there is a buffer, okay, where incoming click streams are stored in that buffer. Now, what I will do when the buffer is full, I will retrain the model. Now, in order to retrain the model, since the model is forgetting past data, I will take data from the reservoir also, which I have stored to retrain the model. Okay. Now, I am retraining the model with both the data in the buffer as well as data in the reservoir to generate or to predict the probabilities of items where items with the top or higher probabilities will be generated as recommendation. This is the process. But as I told you earlier, I cannot store entire data, whatever is coming into the reservoir, whatever is coming into buffer, I cannot store into the reservoir. Okay. Now, what happens if I replace the entire data? Again, as the time passes, model may forget it. Okay, as the time passes, model may forget it. Suppose say a user with a unique preference has this kind of purchase. A white color shirt followed by a pink colored pant. Usually we do not prefer pink color pant. Okay. But this is an assumption we are assuming. So the model might have trained one time with this pattern. Okay. As the time eventually goes, the model will forget when the same user have arrived in the system. We will not be able to recommend pink colored pant. Then our recommendation system fail. We are not generating appropriate recommendation to the user. So we need to have certain sampling design of sampling strategy to replace click streams from the reservoir. Okay. Similarly, we need to able to judge what to be stored and what not. Say sampling of click streams is needed to select the click stream to store in the reservoir. Okay. Now again, there is one more scenario of overload. I am saying that I am retraining the model with sampled interactions from the reservoir as well as data from the buffer. Let's say it takes some amount of time X. Okay. By the time taken for retraining X, the buffer is filled in M seconds, where M is very much less than N. So again we will be missing some amount of data here due to overflow condition. That is known as overload. So we need to prevent overload scenario along with the catastrophic forgetting. These two are the major design issues when you are talking about a reservoir. Okay, now what are the challenges in building streaming session-based recommender system? See, I am working on user interest drift identification in the clickstream data. That means UID capturing in SSRS. But I do not have streaming data. Why? I cannot get the streaming data from Amazon or Flipkart and anything. What I have to do, I have to enumerate the streaming nature on the static data. So this process of enumeration I will be discussing. Say data set is having some 1,000 entries. Okay, 1,000 rows. Okay. I will divide into 5 chunks. Each chunk will be having 200 records. Now, this 200, what I will do, initially I will be having test set. Okay. I will train my model using this data, using data in the buffer as well as chunk C1 of reservoir. Okay. Where do I get the chunk? From the reservoir. Okay. I will train the model and again I will test with one more chunk of the reservoir. I will note down the performance. Now, I will repeat this training process with a new chunk C2 and I will check with chunk C3. This way I will repeat with all the chunks. I will take the average performance of the user and denote it as the performance by my model. Now, one more major issue is handling recurrent user interest drift that we have discussed earlier. Okay, and one more difficulty is determining the accurate reservoir size. Why? Why is it difficult to determine accurate reservoir size? Why is it difficult to determine accurate reservoir size? Because we have so many interactions. Okay, we have 1,000 interactions, but we cannot have all the 1,000 in the memory so that we are maintaining a reservoir. But we cannot determine the size of reservoir as say 200 records because you may have 400 varied patterns which cannot be eventually stored in 200 records. So that is one difficulty, that is determination of accurate reservoir size. Now, we have discussed about a recommendation system, session-based or session-aware recommendation system, as well as streaming session-based recommender system. Now, we will see the open issues in brief. We have already talked about it, so I will briefly go through this. One is handling a cold start scenario that I have said already. Cold start means for a newly entered user or item, you will not be having ratings to recommend. And long-term versus short-term preference that we have seen in one example where the long-term history of the user will be related to different items and short-term current searches will be different. One more issue here is user preferences may continuously change. Suppose I bought black colored shirts or t-shirts earlier, but I prefer not to wear black anymore. In that case also, considering long-term preference is a challenging. User interest drift identification, as we have discussed, we need to identify the current preference of the user. And usage of contextual factors, as we have discussed about Diwali diyas, as an example, we need to we can consider it, but we cannot say that will be applicable to all the users. And accuracy versus diversity trade-off. Some users may like to view only the similar items, and some may like to see the diverse items. Okay, this we need to have a trade-off, like how to balance accuracy versus diversity. And if we take a reservoir, as we have discussed, designing the sampling strategy or replacement strategy is one open issue, and the sampling mechanism is also an open issue. Like how much data we need to retrain the model, and how we have to take the previous data, which data we have to consider, all those things. Okay, these are some of the other approaches. Knowledge based recommend intuitively session based recommender system will be considering all these things also in a way or different way. If you take a knowledge based recommender system, it will consider the session interaction as well as the description of the item. Context aware, which I meant as contextual factors. Time aware recommender system, it will take the time into the consideration. Suppose if someone searches some items at the night, or most users may search few items in the morning, those kind of thought. And multi-armed bundled based recommendation, this is part of reinforcement learning where we will use a multiple arms. Utility based recommender system, where we will consider how much useful a recommended item to the user in that particular scenario. Demographic base, as I said, will take a country, age, okay, sex of the user. These things will consider. And conversational recommender system, it's all your chatbots which you are seeing in the say online SBI application. How may I help you? I guess it is Siri or some name it is there for it. So you will be selecting the options from it, and it will be giving a proper advice to the users. And these are the some of the references. Okay. With this, I come to an end of the session 1. Here we can take a lunch break and we can meet around 1:45 or 2. Over to Vishnu sir or Kiran ma'am.
Yes, thank you, Chaitanya, for delivering the content effectively. And I request the participants to join the session at 2 p.m. after your lunch. Thank you. Thank you. And we will be sharing the link, attendance link in the WhatsApp group, so that you please do mark your attendance.
And one small announcement. At 2 o'clock in the later session, we will be having hands-on. Means first I will be discussing about the two problems that we are going to solve for the day. First, I will briefly explain them that you will be working out, and at the end of day, say around 4:30, we'll be having 2 hours time. You can work on it at the 4:30 or around. You can. I will be sharing my code and I will be explaining it. Okay, is this fine, sir?
Yeah, yes, fine.
Yeah. Yeah. Thank you.
Yes,
That's
thank
it
you.
for the session.
Yes, we'll rejoin the session at 2 p.m. Thank you. Thank you.
Sure, sir. Thank you.